work in another problem, mass to mass, that we have ammonium nitrate decomposing to dinitrogen monoxide and water. So here, what you have first, the first thing that you need to do is organize your data. So we have the given data, right? So the given data is this over here. So they are giving us the initial mass of ammonium nitrate. And they ask us to find both mass for both products, Na2O and water, dinitrogen monoxide and water. So we have mass, and you want a mass of reactant, you want to find mass of the products. So first thing, we have grams. We cannot start never with grams, because just remember, 1 mole of water, for example, is 18 grams, right? That's smaller mass. 2 times 1, because we have 2 hydrogens, and the mass of hydrogens 1, and the oxygen 16, so we have 18 grams. And 1 mole, for example, of CO2, so we have 2 moles of oxygen, so 2 times 16, right? 32 plus 12, that is mass of carbon, will be 44 grams per mole. So see, the mass is different, completely different. So what is equal here is number of moles. So first we need to convert mass to moles, and then find out the moles to the equation ratio here, so which is 1 mole of ammonium nitrate will produce 1 mole of dinitrogen monoxide and 2 moles of water. See, I'm reading the coefficients here, 1, 1, and 2. This is the ratio, okay, of the equation. So to find out moles, we need the molar mass, right? After we found moles, I need a mole from of dinitrogen monoxide. So we're gonna use the chemical equation ratio, the one that I just showed you over here. And then we can find the mass, the final mass to the molar mass. So we have 45.7, and we have the molar mass. So why it's down here? Because I need to cut off this and have moles. And this is the mole ratio. 1 mole of the nitrogen monoxide will be produced if you have 1 mole of ammonium nitrate. And now I have the molar mass, right? This is the molar mass here from the dinitrogen monoxide. So now I will cut off the moles, and they're gonna have grams. And they're gonna do the same thing. Look at this, same thing, to find out the mass of water. So the only thing that will change here is over here the mole ratio and the molar mass, because now here molar mass is the water, 18 grams, and here's the mole ratio, 2 moles of water. Look here, 2 moles will be produced if you have 1 mole of ammonium nitrate. So it's easy to find the mass, okay? So you need to multiply all, this is a big fraction, right? So you need to multiply all the numbers that you see here, say times 2 times 18.02, divide by the products of the numbers that you have here, 1 and 1. Okay, then we're gonna find this. Okay, so next is mass to volume. And here, when they ask you volume in a problem, is because we work with gas. And what you need to remember here is that 1 mole of any gas will occupy 22.4 liters. Remember this. Doesn't matter if it's CO2, doesn't matter if it's hydrogen gas, oxygen gas, will always occupy 22.4 liters. So the first thing that we need to do here, you don't even need to read. Remember, if we start with mass, we need to convert to moles. And then we're going to use the mole ratio, the equation, right? The fractions, like if you have 1 mole of carbon, for example, how much how many moles are going to produce of CO2. So we need to look to the equations. And then we're going to find the mass of the product. And to find the volume, you're going to need to find, we're going to find moles of the products. So, and then with the molar volume, we're going to find the volume. So let's practice. And you must be asking yourself, like, why I need to learn this? Because it's so important to calculate volumes of gas as well. For example, azide is what we have inside of your, will be produced in your airbag when it's insufflate, right? So the importance here about the volume is like when your car crash, this will start over a reaction, and the reaction is really fast. So the gas produces really fast reaction, and will insufflate this bag. So if you have a little sodium azide, we're gonna have, so the airbag will not fill completely, and will have a low protection of the person in the vehicle. But if you have too much sodium azide, the bag can break from the excess of gas pressure, and we're gonna lose all the protection. So this is very important to calculate, okay? So let's go to the smaller to calculate volume. So if you start with grams, we need the molar mass to find moles, and then the chemical equation ratio to find moles, and then again we're gonna use the molar volume, right? And then we're gonna find the volume of the product. If they give us the liters already, the volume, so again we're gonna use the molar volume because we need the number of moles, right? And then moles, we're gonna find moles, chemical equation, and everything is the same. So just remember, we always start with moles. And this example, they ask how many liters of hydrogen are produced from the reaction of 0.165 of aluminum metal with diluted hydrochloric acid at STP. Remember, STP, that means that 1 mole of any gas will occupy 22.4 liters. Okay, that's what the volume. So here, our given data is 0.165 of aluminum. So what are you going to do? Always remember to look if the reaction is well balanced, because if it's not, you need to balance first, okay? So here we have the mass of aluminum, and then the molar mass of aluminum. Then you find this in your periodic table, okay? Go to periodic table, you're gonna see the atomic mass of the elements. If it's a compound, you're gonna use the atomic mass of individual elements and then multiply by the subscript if you have a subscript like hydrogen. So I have 1 gram, 1.0009 grams per mole. So since I have 2, I need to multiply by 2, so I have 2 grams per mole. Okay, so that's molar mass. And then we have the chemical, we have the chemical ratio over here. So see, 3 moles of hydrogen will be produced if you have 2 moles of aluminum. So if you don't balance, those values could be wrong. Okay, and finally, I have here the volume. So the molar volume to find the volume that I want. So we're gonna cut off this, and we're gonna have just liters, so 0.205 liters of hydrogen. Okay, so in the next video, we're gonna talk about volume to mass problems. So that's it. That's all. So now we're gonna